Welcome to Calculus. We conquer our fears and flex in the face of adversity. On this episode, Stevenson will demonstrate
Another set of functions that have inverses are trig functions. So what I have for you is the list of 6 trig functions and their inverses, the derivatives of their inverses, These are in your textbook. However, the cosine, arccosine, arccotangent, and arccosecant are not because of the identity. They show that there's an identity relationship. And so they tell you can use this other, I think they call them cofunction identities. I'm drawing a blank at the moment here. But basically what I want to show you is if you know arcsine, arctangent, and arcsecant, you automatically will know the other. For example, look at arcsine and look at arccosine. Do you see how the formulas are exactly the same except arccosine's negative? Look at arctangent and arccotangent. Do you again notice the formulas are exactly the same except arccotangent is negative? And lastly, with arcsecant and arccosecant, it's the same relationship. Formula is the same except arccosecant is negative. These formulas are things that you need to make flashcards with, but if you know 1, 2, 3 of them right here, then you essentially know all 6. Okay, and so I just want to show you a couple quick examples. These are all just figure out the inside and plug it into the formula. That's it. I want to show you a few examples on how you can use those arc, trig, inverse rules and derivative rules, and they look really complicated, but really all it is just plug it into the formula and simplify where you can. So let's look at an example. Here's the first one. It says find the derivative of the inverse of sine function of x squared. So the derivative of arcsine is the formula of 1 over the radical of 1 minus u squared times du dx. So the first thing you want to do is figure out what's your u. In other words, what's inside your arcsine function. So this is my u function. It's just x squared. Next, what I'm going to do is plug it into my formula. So remember, the derivative of arcsine is 1 over the radical of 1 minus u squared. See, there's the u times du dx. So there's the du, showing the derivative of x squared. Okay, now from here you just simplify. Well, x squared is just x to the 4th power. And the derivative of x squared is just 2x. And there it is right there. Here's another example of how inverse trig functions can be used. So it says a particle moves along the x-axis so that its position at any time t greater than or equal to 0 is given by this position function here. And notice it's arctan of the radical of t. What is the velocity of the particle when t equals 16? Okay. First things first, velocity is the first derivative of position, right? So my position function is an inverse tangent function. So the first thing I need to figure out is, well, what's the derivative of it? And then I'm going to evaluate it at 16. So first thing is, we have to take the derivative of arctan. Now, if you look at your rules for arctan, the derivative, it's 1 over 1 plus u squared times du dx. It's one of the really nice ones. We love arctan. Super easy. First thing, we have to figure out what's the u. That's my u. It's t to the half power, or radical t. So here is my structure. 1 over 1 plus u squared, there's the u, times the derivative of the inside u. There's the du right there. So what does this turn into? Well, radical t squared is just t. And then the derivative of radical t is 1/2 radical t, but the radical t is in the denominator because you end up with a negative 1/2 power. Now that's just the derivative, that's velocity, right? So we're going to evaluate that at 16. So that's it simplified. So what you're going to do is plug 16 in and you end up with 1 over 136. Here's a third example that I want to show you. This is with arcsecant. Now, this problem's already worked out, and I want to kind of point out some elements here. First thing we can see with arcsecant is, what is the u? Well, the u is just 5 times x to the power of 4. But remember, the arcsecant and the arccosecant formulas are actually the most complicated. So if you notice, you take the u and plug it in here and here. And then this is your du. This is just following the formula of arcsecant, okay? From here, you just simplify where you can. So if you look at the inside of the radical, the 5x to the power of 4 quantity squared turns into the 25x to the power of 8. Now the absolute value goes away because x is raised to the power of 4, and so because the power is even, you're always guaranteed a positive value, so the absolute values can drop. And then the derivative 5x to the 4th, as you can see, the du is 20x cubed. Then from there, the 20x cubed can actually go to the numerator, and that 20 and that 5 will simplify to 4, and x cubed over x to the 4 simplifies to 1x on the bottom.